following combinatorics problem, and we're asked to count the number of ways the alphabet can be arranged with no two vowels together. So basically what this is asking, so you have the alphabet A, B, C, and so on, all the way to X, Y, Z. And that is one arrangement of the alphabet. Another arrangement has G, H, X, blah 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 blah, J, F, K. And there is a lot of ways to arrange this. If you think about, if you want to count the number of ways how many permutations of the alphabet there are, you can do it the following way. Well, if you put placeholders for the letters, and you've got 26 placeholders for all the letters, well, we've got our alphabet set here, and to count the number of combinations we can do it in the following way. This set has 26 members, so if I just call this set A, and it's got a cardinal of 26, it's got like a size of 26, so you want to count number of ways. So how many possibilities are there for the first letter? Well, there's 26 possibilities for the first letter. We then go cross something off, cross one of the letters off. How many letters are remaining? Well, we've taken one already, so there's 25. And then there's 24, and so on, all the way down to 1. And we call this 26 factorial. And it's the product of 26 times 25 times 24, all the way down to 1. And we're looking, how many ways can the alphabet be arranged, and here's two arrangements here, such that no two vowels are together. This is quite a hard problem, and the solution to it is pretty nice, I think. So we don't want to need two vowels together. So how can we separate two vowels? Well, we can sort of let each side of a consonant have like a wall. So for example, let's just do it like so. Let's forget about this, we'll get all the consonants over here. So we've got B, C, A, B, C, D, and then E, and then F, and then so on, all the way down to Y and Z. So here are all our consonants, and let me just quickly write up here. So the vowels are A, E, I, O, and U, and there's obviously 5 of them, and the consonants are all the remaining ones, and there is 21 consonants. So we've got our 21 consonants here, and we want to make it so no vowels can be together. And like we're going to do with this case here of just arranging the amount when there's no restrictions, we now have the restrictions of a vowel being there. So let's change our way of thinking about this. So we've got 21 letters here, and we can arrange them like so. So we've got 1, 2, 3, 4, 5, 6. I don't know why I'm counting, and then actually I'm going to change my mind. So we've got like 1, 2, 3, 4, dot 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 dot. I think that's enough. So we've got B. Actually no, yeah, B, and then we're going to leave a space. And then we got C, put a space there as well, and then leave a space. D, there's going to be a space there, and then on this side we've got space Y, space Z, and on the end here we've got another space. So what you may ask, why do we have these spaces here? Well, these spaces are reserved for vowels only. So if we didn't have these spaces sort of act like guards. If we didn't have these spaces, then vowels could go anywhere and they would be able to get into each other. However, now these spaces are here, and they're only allowed to be in these spots, these alternating spaces, then it stops any two vowels being together. So first of all, we want to find the way of arranging all the consonants. Well, we've got 21 consonants here, and there's obviously going to be, if there's 21, there's 21 spaces. So like before, there'll be 21 factorial ways of arranging the consonants in each of these spaces. And how many spaces for vowels are there? Well, you've got one here starting from 1. So if you consider counting like this, then you're going to get to the point before the last letter where there's been 21 consonants, so there's going to be 21 red marks here. So there's 21, and then look, there's one more, pardon me, 21 there, and then there's one extra on the end, so there's 22 spots. So we've got 22 spots, and how many consonants do we have? We've got 5 consonants. So we want to distribute 5 consonants throughout these 22 spaces. And you may be familiar with it. This is the same NCR notation, which is n factorial over n minus c factorial times c factorial. And this is the way of arranging C objects from a bag of n, basically. And this is what we're doing. We've got 22 spots and we want to pick 5, so we're choosing 5 out of 22 with this n choose 5, and we're doing 22 choose 5. So we've got the number of ways to arrange our consonants, and for each arrangement of consonant we can multiply this, there is 22 choose 5 ways of arranging our vowels. So for example, this is one arrangement here. You can choose I there, leave this spot empty, E there, and then over the last spot we've got I, and then the other 2 vowels can be distributed somewhere else in these red markers. So you may say, is that your final answer? And you'd be wrong, because you need to add one more little factor in. So for each selection of 5 vowels out of the 22 spots, there is 5 factorial ways of rearranging them. Because there's the 5 vowels A, E, I, O, U. How many ways can you rearrange this? This is 5 factorial, so you can multiply this by 5 factorial, and that is your final answer there. 21 factorial times 22 choose 5 times 5 factorial. That's how many ways you can arrange the alphabet such that no 2 vowels, or no more than 2 vowels, you could say, are next to each other.